This lesson for number 5, we're moving into part E. We got a little bit of triangleception going on with these next few examples. A triangle within a triangle. I want you to see the two triangles. We have the smaller triangle and we have the larger triangle. I like to draw them off to the side. So I like to draw my small one. Let's see, that's x, that's 15. We're going to assume that this 30 is actually talking about the hypotenuse because the x is right here. So why would you have 30 when you know it's x? Okay. And then we have the bigger triangle. And I'm going to get these from the bigger lengths here. So 77, 55, 110. Now we can do the same thing we've been doing with finding scale factors. So I know that I'm going to have to do 77 times something to get to x. So I'll just pick one of these sets of sides. I'll go 110 times something gets me to 30. So I know 110 times my scale factor gets me to 30. I can divide both sides by 110. And I get 0.27 repeating. And you can either write those as a decimal or keep as a fraction. I don't think I've done one where I've written it as a fraction, so I'll write it as a fraction this time. I can convert this back into a fraction using my calculator, because right now my calculator is showing me like 0.272727 and so on. If I hit the math button and then hit enter for frac and hit enter again, it's going to give me 3/11. And now when I go to find the other length, I can just do 77 times 3 divided by 11 in my calculator. So 77 parentheses 3 divided by 11. And I get 21. Or you could do it the way that we did in our previous examples where we just did like answer times 90 for all of those. That works too. Okay, let's do it again on the next problem. 26, 14, 20. $49.91 x. So I know I'm going to have to get, I'm going to have to multiply 20 by something to get me to x, which means that I can take either of these from the blue and then get it over to the green. So I know 14 times my scale factor will get me 49. I can divide. I get 3.5. And now we can multiply 20 times 3.5. And we get 70. Okay, for these next two examples, I'm just going to warn you, they get ugly because the numbers are just a lot bigger than I anticipated, so my bad. Don't be afraid of big numbers. They're going to work out the same way. They're just going to be ugly, but that's why we have calculators. So I have two triangles. There's my small one. 55, 40. We don't know the length of CP, but I see that I have x here. And with PE being 54, well, if I want to find CP, I can just subtract those. So this becomes x minus 54 as that side of the blue triangle. Now I can take my bigger triangle, I got x, I've got 112, and then I have to add these two together. So 55 plus 99 gets me 154. Okay, notice how now I have more than one x going on here. We have two x's. So this is going to be super important because now, like, finding one scale factor to the other, like, I'm going to have to multiply x minus 54 times something to get me x. And that's just going to be a hot mess to deal with. So here's my suggestion for you. If you have more than one x, represent the scale factor as a fraction and cross multiply. Here's what I mean by this, is that the way we found our scale factor through every other problem on these pages, notice here, 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 we're dividing for everything. And so the scale factor was like, oh, 75 divided by 30, 30 divided by 110, 49 divided by 14, 225 divided by 30. So instead of actually doing that, we'll just represent it as a fraction. For example, I know that I can do 55 to 154. And so I can say, all right, I can find the scale factor by doing 55 divided by 154. I could also do it as 154 divided by 55. That's okay, as long as I'm consistent in direction between the blue and the green. So because of this, for this example, I've chosen to say, okay, 55 to 154, so blue to green. That means when I go to set up my other fraction, I can go blue to green. And so what this is coming from is that our scale factor is we find scale factor through division, aka the fraction. That's where that's coming from. And so what we're saying here, what I've set up in this equation is that, oh, the scale factor between these two is going to be the same as the scale factor of those two. Meaning when I divide the two, I will get the same value, the same scale factor. And so by setting up those two fractions, now what I can do is cross multiply. Meaning we're just getting both expressions out of the denominator. So I can take 154 times x minus 54 and set that equal to 55 times x. And now it's an equation that I can solve. So I can distribute 154x minus, I'll do 54 times 154, 8,316 equals 55x. Like I said, don't be afraid of big numbers, it's the same thing. I can subtract 154x from both sides. And I'm going to move the rest of it up here so we can see it. So negative 8,316, 55 minus 154 is negative 99x. And now I can divide both sides by a negative 99. So negative 8,316 divided by negative 99. And I get x is 84. Okay, we're gonna do another example, and just keep in mind that we are not afraid of big numbers because we are strong, brave math students who can handle anything thrown at us. Okay, I got 78, and it looks like we're once again going to have to use subtraction to find the other piece of this blue triangle. So if I come to my big triangle, get 91, I get 8x minus 13. Well, to get my missing piece of my blue triangle, I have to take this 8x minus 13 and I have to subtract this segment NH. So 8x minus 13 minus another 13 is 8x minus 26. Once again, we are now going to represent our scale factor as a fraction because I have multiple x's going on. I have an x in my blue triangle and an x for my green triangle. So let's say this time we're going to go green to blue because last time we went blue to green, so why not switch it up? So I can go 91 to 78. So I can say 91 over 78. Because division is how we find a scale factor, which means since these are similar, they will have the same scale factor as if we were going to divide 8x minus 13 by 8x minus 26. And now that I have my scale factor represented as a fraction, aka dividing, we can cross multiply. So I can take 78 times 8x minus 13, and I can set that equal to 91 times 8x minus 26. And we're going to have a great time solving this. I can distribute 78 to 8, so 78 times 8 gets me 624x. And now 78 times 13 is 1014. So I do minus 1014. Now I can take 91 and distribute it. 91 times 8 is 728x, and 91 times 26 is 2,336, so it's minus 2,336. All right, now it's just solving an equation. We can do this. Wow, especially if we zoom in a lot. All right, I'm going to start by subtracting to get my x's on one side. So this is going to leave me with negative 1014 equals 728 minus 624 is minus 104x. And now I'm going to add that 2,336. I get 1,352. Excuse me. Oh yeah, that's right. And also, I made a mistake. This is not a negative 104. That's a positive 104. Glad I caught that. Okay, so 1,352 equals 104x. And now I can divide both sides by 104. And all of that just to get that x equals 13. Well, there you go. Wasn't that exciting? Okay, if you have questions on that, please contact your teacher to go over it again. Number 6, you're going to find is not nearly as complicated as all that. We have more triangleception. That's the theme of part 2 is triangleception. But I want you to notice that, well, first here's the small triangle, and then we have the big triangle. What I want you to notice are these little congruent markings that we have going on. And so let's say that this segment HI was 3. Well, based on the congruent marking, that makes SH also 3. Which means if I was to draw them out separately, here, we're actually going to do it a little bit, start with the big one, and then go to the small one. If this was 3, well, I have 2 of those to give me that same length on the other one. Let's say maybe this was a 5, and because of those congruent marking, that's also 5. So I'd have a 5, then I have to double it to get 10. Do you see the scale factor at play here? That scale factor is just times 2. So that means if I have 10 on the big one, what am I going to do to it to get to the little one? We can just divide it by 2. We get 5. You might be wondering, but we said the bottom was 5. I made up those numbers. This doesn't have to be 5. Point is, you're doubling. So that means this got cut off a little bit, so let's go ahead and fix that. If this is a 16 and I want to find CD, we can just divide by 2. If I need to find EG from 9, oh, we can just times it by 2. Oh, that's a breath of fresh air after our last 2 examples, huh? So now we're going to throw some algebra in there for you, because what is life without having to solve for x? Boring, obviously. Here's what I know. If I know the scale factor for these is automatically 2, which it is, because we're always doubling, that's what these little congruent markings mean, then I know that I can always take the inside length and times it by 2 to get the outside. So I can do 2 times x plus 17 equals x plus 27. And now this really feels like child's play after the big crappy numbers we've been to. 2 times 17 is 34. Can just minus x. And I'm going to minus this 34 as well, because those cancel, those cancel. 27 minus 34 is -7. Notice the question says we need to find EF, and so we can plug back into EF. So since EF is x plus 17, that's like -7 plus 17, which is 10. Cool. Let's do part F. Once again, because I see all of these congruent markings, I know my scale factor is 2. So I'm going to do 2 times 2x minus 13 equals x plus 4. You can distribute 4x minus 26, x plus 4. And now I'm going to get all my x's on one side. Those canceled. Now let's add the 26. Now that should be plus 30. There we go. And it's not plus, it's equals 30. It's fine. We're doing fine. So x equals 10, and we're trying to find JL, which is x plus 4, so I know that's going to be 10 plus 4, which gets me 14. And there is 9.2 in all of its glory.